So welcome to section 4.3, writing linear equations in point-slope form. Now, the first thing I want to make sure I let you know is that point-slope form is another form of a line. It's no better or worse than slope-intercept form, it just tells you different information. Because slope-intercept form tells you two pieces of information, the slope, which we called m, and the y-intercept, which we called b. If you think about it, point-slope form is also going to tell you two pieces of information. It's going to tell you a point, and it's going to tell you the slope. So this is just another way of writing an equation of a line. So what is point-slope form? Well, for point-slope form, you need to have a point, which we will call x1, y1, and you need to have the slope, which we will still call m. So point-slope form says, well, for any line for your equation, you can just say y minus your y-coordinate is equal to your slope m times, in parentheses, x minus your x-coordinate. So let's look at an actual example of what this looks like then. Also, so you know, I will abbreviate point-slope form as PSF, just so it doesn't take up as much space on the paper. So write an equation in PSF of a line with a slope of 2 that passes through the point 4, -3. Well, when we were trying to find slope-intercept form, we had to jump through a lot of hoops to be able to figure this information out and how to graph it or what the equation is. But in point-slope form, all you do is you take your y-coordinate first, and you do y minus your y-coordinate, so y minus -3, equals your slope m, which we know is 2, times x minus your x-coordinate. You're done. That's it. It's a very easy one to take that information and find an equation of a line for it. And that's all the more there is to writing an equation in point-slope form. Now, if we need to graph an equation in point-slope form, well, remember, you still know your slope is what's multiplied by the parentheses, so in this case, 2/3. And then your coordinate is x, oh, let me scroll back for a second. It's x minus x-coordinate and y minus your y-coordinate. So this one, it's x minus 3. So your x-coordinate is going to be 3. But your y minus, well, for it to be a plus there, that means it had to be minus a -2 in order for it to change to look like a plus. So since it was a plus, your answer is going to be a -2 for that point. And now to graph it, all you need to do is find that starting point. So you go right 3, down 2. You've got your starting point. And then your slope says you go up 2 and right 3. So if we go up 2, right 3, we'll have our next point. That's enough for you to connect the dots, and you've got your line. And that's all there is to graphing this. You just have to watch out for that changing of the minus negatives that are disguised as positives. So let's look at another one. We need to go from this line to find the equation. Well, first thing I would do is figure out what's the slope. What is that m? Well, our slope here says we would go down 2 and right 1, 2. So we went down 2, so -2 over right 2 would be +2, or in other words, -1 over 1, which would equal -1. Now we have a point. You can choose either point, but I'll probably stick with my positive answers here. So then we'll have a y minus your y-coordinate equals your slope times x minus your x-coordinate. Oops, not x minus x. It's x minus your x-coordinate, which is also 1. And that's the equation of your line in point-slope form. If you wanted to go and use your other line or other point for this, you could. You would then have your x-coordinate would be -1, so that'd be minus a -1, or a plus +1, and then be y minus 3. This also would work. It does not matter which point you choose when writing the equation of the line. So now we've got one last word problem. Excuse me, one last word problem, and then I will let you go and start working on your homework. So you're designing a sticker to advertise your band. A company charges you $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. Write an equation that gives the total cost in dollars of stickers as a function of the number in thousands of stickers ordered. Find the cost of 9,000 stickers. Well, the first thing that I would notice is that, hold on, I need to cough. Sorry about that. The first thing I would notice is that it costs a consistent $80 for each additional 1,000 stickers we get. So, in other words, that's our slope. The amount that it changes by each time we change is $80. The other thing I'll notice is we have a starting point. And our starting point is that for our first 1,000 stickers, it's going to cost $225. Well, another way we can think about that, since this wanted us to write it in terms of thousands of stickers, is at 1,000 stickers, or just one in this case, how much did it cost? It cost $225. Well, now we have a slope, we have a point, we can write an equation in point-slope form. So y minus your y coordinate equals your slope, x minus your x coordinate. And what it wanted us to do then is find the cost of 9,000 stickers. Well, all we have to do then is we have to just plug in 9 for our x, and we'll see what happens. So when we do that, we'll have a y minus 225 equals 80 times 9 minus 1 is 8. 80 times 8 is 640. Y minus 225. So now we can go and add 225 to both sides, and we'll come out with a total cost of $865 for 9,000 stickers. So that's all there is for this section. So if you have any questions, shoot me an email, and as always, good luck.